Well, I had a lot of questions regarding that other control panel I built there, so I had to build another one of these panels for a Christmas present. So I thought I would record small chunks of everything I did on the build-up, so that if anybody was interested in building one of their own, they could. And I'm just going to start off with the finished product. If you just started at the beginning and seen that raw box, and you'd probably get bored and stop watching, but this way you can see the final product here. It's a fair amount upgraded from my original model. As you can see, this one's got the a built-in LCD display here. I don't know if you can read the writing on it there. Can't really see it with the camera, but basically there's an LCD. It can display whatever you want. Right now it's displaying the humidity and the temperature. It's got a couple digital inputs that right now I just did a demo program, and basically the digital input goes to the Mega there and tells it to do a function. You know, each switch has a different function, and you could use it for changing set points or manual function or whatever. This box is pretty universal. You could use it, you know, for any project you got going on at home there. Basically, the way I've laid it out is on the bottom is you have all your power, stuff like that, your relays. I'm going to go into it in detail later on in the build. Also, there's the APC wireless function like my other module. This time I put in 2 power supplies. I had some problems with mine, so I put in two power supplies this time. An extra circuit board here. Honestly, I think this box isn't quite done yet. One of the first things I have to do, or one of the last things, is just move this antenna to the outside. It's transmitting at about 400 megahertz, which is actually pretty low and has a lot of penetrating power. And on my greenhouse project, I just left it in there. It's no problem because I'm only going like 50 feet. But for this application, I'm going to put it outside of the box so we can take advantage of the full range of that device. And then the other thing, of course, that still needs to be done to this is I need a real-time clock. I'm going to put that on this circuit board here. Basically, it's right now my greenhouse, the timer is off of daylight, so once it gets daylight it starts counting, and it's roughly 1 second, and it keeps counting and counting, and the time is based that way. Works alright, but I think if you had a clock, like a real-time clock, it would work a lot better. So I'm going to do that, and just temporarily I have a little humidity temperature sensor right there, just kind of to demonstrate. And as well, I've got the data acquisition program running here. You can see it's not labeled correctly, but the humidity and the temperature are showing up here if I breathe on this thing here. Should be able to see this climb up here. There we go, starts to climb up. This one's obviously the humidity. And the charting and stuff. And this is software I got from work, so I can't really give it out, but you can get some stuff off the internet. I've heard of a bunch of free stuff that you can actually design your own. I'm going to show you something else here. Basically what I've done for the data when I send it across is it's just widths identified, so I can show you that. I'll just go to the Arduino here and make sure I'm on column 8, open up the serial monitor. Should be able to see that. That's basically what the data looks like coming out. There's identifiers in front of each channel, and then ampersand and exclamation point to identify when new pieces of data are coming through. So yeah, let's get started. Doing this kind of economically. Some of the parts are used. Stuff we're going to be using: get this all at equal, but terminal blocks, the interconnect strips, some relays, cable glands, heat sink, wire ferrules, bolts. I got this enclosure off of eBay. Didn't come with a backplate, so I went to the local metal shop and they punched me out a piece of 1/8 aluminum here I'm going to use for the backplate. And I was able to scavenge a bunch of used terminal blocks. So I'm going to take that all apart. Unfortunately, this is not a DIN rail type, so it's not going to be the best looking, but it'll look alright. I got some more of the DIN rail and the Panduit wire track here. So yeah, we're going to go through. It's just going to be a brief video. I can't really film all of it, but I'll go through it kind of step by step. I guess the first piece, what I'm going to be doing here is taking this panel, marking it, drilling holes in it so it'll mount in here. Then I'm going to pull it out, and then I'm going to plan out, mount all my Panduit terminal strips, and do that before it actually gets mounted in here. So I'm going to go ahead and do that now. Okay, so what I did to measure that is I measured the distance between these two, then subtracted the difference off of this plate, divided it by 2, and then I used my calipers here to just etch the marks of where I'm going to put the holes in here. I'm going to go ahead and use a hammer and a center punch to mark the holes, and I'm going to drill it. So when you're drilling these holes, you always want to start off with a bit that's much smaller, or else what you'll find with if you start with a larger bit, it'll wander off and your hole placement won't be very accurate. One other thing you can do is after you're done drilling the holes, use a larger drill bit to clean up so there's no burrs on there. And I'm just going to use a step bit. And yeah, it just cleans up the hole there so you don't have any sharp ends on it. And then we'll just see if she fits. Just like that. And now you're going to want to make sure you mark the something to identify the top and the up so that it all lines up again when you're done. Next I'm going to be cutting the Panduit. And to do that, basically I've just got a portable bandsaw here set up. Make sure you put it on a low speed when you go to cut it, or else you're going to end up with a lot of problems. Next we're going to place these. I'm going to mark the holes I drilled out with a paint marker. Then I'm going to bolt them on there. There's another thing I forgot to mention, that I've actually offset the Panduit all the way around to maximize the room available in the box. The one problem with that is it won't fit in the opening with all the Panduit mounted. So you can mount the two sides, but what I'm going to do for the edges is I'm actually going to tap out the holes for mounting it, slide it in, and then just screw the last pieces of Panduit on. So I'm going to tap those out now. And there it is with all the Panduit mounted. Now I'm going to work on mounting the DIN rail, the other type of rail, and as well the Arduino and circuit board. I'm just going to cut the rail with a chop saw here. I've already measured it. You're going to want to use an angle grinder to file down all the sharp burrs and shit off of your rail here. Once you've got all your DIN rail mounted, I guess what I'm going to do now is cut out a piece of plexiglass here, install it right there, and I'm going to use that with some standoffs to mount the Mega and then a circuit board for transistors and whatever other circuitry you might need to add to this project. What I'm doing to mount the proto board here is just some nylon standoffs, and I'm going to do that for both those boards and the Arduino as well. Here it is with everything mounted up. And now we're just going to drill some holes and install it in there. And to mount this, all I've done is put some bolts in backwards, tighten them down, and then this is just going to slide on top. And then I'll just put nuts on top of those there. That'll hold the whole assembly in place, and you can take the printed circuit boards off or your proto boards off if you need to, or when you need to work on them. Same with your Arduino if you ever need to replace it. Next, we're going to drill out the holes for the cable glands, and I'm just going to use a drill press with a two-way adjustable vise there to get the holes nice and even. You just measure the distance, then divide by the number of holes you want to put in there plus 1, and it'll give you even spacing. Yeah, that's good. Now we're going to go ahead and mount the relays and the terminal blocks here. In addition to that, I'm also going to build some brackets off the bottom of the box here, so that we can actually mount it onto something, and we need to get that in there before we put the backplate in there. Because once the backplate's in there, we're not going to be able to access that. It's important to make sure everything is watertight. This box came with little gaskets and stuff for installing on these bolts. As well, installing all these cable glands here, you want to make sure you use silicone on all of them, or get the proper O-ring sealer at the electrical wholesaler. Here it is mounted in the box. I had to carve out the pounder to get the bolts on. See there. And now we're just working on pulling out the numbers that were on the terminal blocks, and we're going to relabel it. When you plan to have a project that's going to last, 5-10 years, the circuit's not going to stay in your head, so it's always good to have everything labeled. And what we're going to do, or what I'm going to do, is have a circuit diagram. I'll have groups of 1, 2, 3, 4 is going to be digital 1, 2, 3, 4, etc., etc. The way I've set up the terminal blocks here, I'm going to have our 5 relays for various water controls, light controls, fan controls, ground terminal blocks, fuse holders for the AC coming in, and the 2 DC power supplies that are going to be inside of this box. Some more grounds. Then I'm going to break up, I'm going to have a neutral block. They're all tied together with this strip in the middle. I'm going to have a hot block that's going to come out of the fuse. Then I'm going to have the 112 volt supply, and then a 5 volt supply here for sensors and stuff like that. And that just makes it really easy when you're setting up and wiring your project. And you can just run in, I need 5 volts or 12 volts, and then the sensor wiring is going to come to here, and then the corresponding side of that's going to go to the Arduino. So yeah, that's how I'm going to lay it out. Another function I want to add to this box is I want to actually put an LCD display and mount it right in the box, so it can list out things like humidity and temperature. And I'm going to have some switches there too, and gives you a lot of flexibility, so that if you wanted to do like a manual water on or a manual fan control, the LCD could give you back some feedback on that. And basically what I'm going to do that is just cut out a piece of aluminum here and fold it in the vise, cut out a hole in it, and then I'm going to mount the LCD and a couple switches in it. I guess as well, you can see right now that I've mounted these power supplies. I'm going to use these for the DC. One power supply specifically for the Arduino. You never want to run the same power supply you're going to run for solenoids and things like that. I did that on my other model and I ended up with some issues, power surging, causing the Arduino to reset. So two different power supplies, one specifically for the Arduino, and I'm going to regulate that with a 7805 as well to run any devices that may need 5 volts like the LCD here. And the second power supply is just going to be for electric over hydraulic coils, or any of the relays that, or any devices that may need 12 volts that have nothing to do with the Arduino, just to keep things separated. Then of course I guess the basis of this thing is the majority of it's going to be off 120. The majority of the things it's going to be controlling, like fans and lights and things like that. That's why we have, of course, the relays. So yeah, that's the next step. So to build my LCD bracket, all I'm doing here is I'm taking a cut-out piece of aluminum, I'm sticking it in the vise, and literally all I'm doing is I mark in here where I want the folds. I set it down, and then all I'm literally doing is smashing it with a 5-pound hammer. I wish I had a press and some other special tools, a metal brake and things like that. Would be nice. I do not have that stuff, so I'm doing it the rude and crude way. It's not going to be beautiful, but it'll serve the purpose. What I've done here is I just used the micrometer, or the digital caliper, sorry, and patched up power, and I'm going to cut in this to mount the display here. So I'm going to go ahead and cut that out now. So I've cut or drilled 4 holes in the corner, so that way when I run the jigsaw through, I don't have to do a hard turn. I can just run up to the edge. Now that that's done, I'm going to drill out some holes here for some switches. I just want to put some switches in. You're going to run them to digital inputs on the Arduino, just for for whatever reason, if you want to have a manual water off on, or some kind of a bypass or functionality for summer or winter use. Just basically put them in there because you never know, you might need them. I'm also going to put in 3 LEDs, one for 120 volt power, one for 12 volt power, and one probably for the 5 volt DC power, just for easy troubleshooting. I've moved everything into the house now. I'm going to start wiring it. You can see kind of the layout here of what I'm going to do. I'm going to put that this display, a couple switches right there. I'm actually going to use a high quality adhesive Velcro so that if you had to, you could remove to repair it. I really dislike drilling holes in these NEMA enclosures. Every time you pop a hole in it, it's just less and less watertight. Bare essentials, of course, the cable glands, but they're all siliconed up. Everything else I'm going to try to just adhere down, especially it's not mounted on a truck or anything, it's just mounted on the side of the house, so a high quality adhesive should be able to hold it. That's what I did with these power supplies here. I could lift that box with those. It's a special 2-sided tape. They actually use it for holding moldings on cars for automotive applications. But yeah, so I'm going to start wiring it. I've finished wiring up the front display or interface there. It's not beautiful. I got the pot there for the contrast. I used a telecom wire, so each wire is actually a different color code, which is going to come in handy later, and I'll explain why. Now when you're wiring up a panel like this, you always run all your cabling first, because if you do your termination and trying to guess the length of wire you need, you're going to end up with a bunch of extra everywhere, and that just makes a mess. So what you need to do, which is what I was mentioning about every different color being different, is identify each wire so that you can strap and run everything exactly where you want it, nice and neat, and then terminate your wires once you have everything in place, and that way everything's exactly the right size. So something else you want to keep in mind of is whenever you're running a cabling into your Panduit, you always want to strip back any insulation if the wire's got any. There's no point in having insulation inside of the Panduit. It just takes up extra room. So what I've done here, you can see, is I've just trimmed back all the extra wire on this, or extra insulation on this, and that way I'm not taking up all the room in the Panduit with plastic. Also, I wanted to show you guys ferrules, and you're probably familiar with them, but if you're not, they're a little piece of plastic and metal, looks like that. And what you do is you just slide it over your wire like that, and you use your crimpers, and you can crimp it into place, and it makes a nice little end. And the nice thing about it too is they make special ferrules, so you can actually double up. You can see it's a little bit wider there, so you can actually terminate two wires into one, and it actually it saves you a fair amount. For example, I only have one block of 4 that are tied in common here that I'm going to use for hot. So I'm going to tie these two hots together into one ferrule, save myself some terminal room there. What I'm working on now is one of the circuit boards. On here I'm going to put the APC 220. It's a pretty simple circuit, just tie it in common with the power. I don't know if I mentioned earlier, but I actually didn't have any 12 volt power supplies, or, well, I had 5 volt power supply, but I had these 2 power supplies. One's 18, I think the other one's 15 volts, both good for over 2 amps. So what I was going to do actually was run them up to this circuit board here, and then I'm actually going to have 2 7812s in parallel with a big heatsink on them for the one power supply for coils and things like that. And the other power supply I'm going to put on another 7812 just by itself, and that's going to be just for the Arduino, nothing else. And then also a 7805 just for like the LCD and any sensors and stuff. And that way the Arduino and the 5 volts and the 12 volts for coils and stuff are all completely independent. But, yeah, that's what I'm going to be working on now. Alright, what I'm doing now is I'm going to put on some heat sinks for my regulators here. Again, I had the 2 in parallel for the larger 12 volt stuff like coils and stuff, and then I had a 12 and a 5 for the Arduino, and then miscellaneous sensors. And all I've done is cut out a couple of chunks of aluminum here, tapped them out to a 440 screw, and I'm going to use some thermal heatsink compound in there and screw those on there. Just like that, so that they can reach their full potential. What I'm doing now is wiring up all the inputs and outputs on the Arduino. So I had a bunch from up here for the display and the switches and stuff. And all the extras, what I'm going to do is run them over to this empty terminal bank here. And what I'm going to have is a, digital, probably digitals 1 through 10, analog ins 11 through 20. Maybe have some analog outs, just a few of them, and then I'm going to have a bunch of serial ports here, and the SCA or SDA and SCL for communicating with different devices. Yeah, I've pretty much finished up wiring it up here. Really all that I got left to do is I'm going to put in a little humidity / temperature sensor just as an example for the fellow that I'm giving this to. Also I have to get that APC working there. I just want to verify and do a little demo program with that. You can see pretty much what I've done is what I was discussing. I ran all the digitals and analogs over to this bank here. Everything that wasn't used already by the switches, the stream. But basically the first 10 are digital, the second 10 are analog ins, and then the last 8 are a bunch of serial ports. The number 0 is actually going to be going to the APC here. Not bad. Panduit's probably about 50% full on this side, probably about 50% full on this side. This one hardly even used, but that's going to be for all the I/O. So basically when you go to wire it, you're just going to pick, well, if you got a 120 volt fan, you'll just run your 120 volts over to your relay, or if you got a 5 volt sensor, you can just take your 5 volts off of this bank here and grab one of the sensor lines. There's some extra free terminal blocks here, run that out. Or if you need, there's that extra 12 volts I was talking about here, that completely independent from the Arduino system. So you could use that to run, like, for example, in my greenhouse, I'm using 12 volts to run the electric over hydraulic for the watering valve. And if that was the case, you just run your 12 volts over to the relay and then out. The system's pretty versatile. You could use a box like this for pretty much anything. It's basically a SCADA pack is what it is, or a SCADA control system. The neat thing about this is you can build it for way cheaper than what it would cost to actually buy a SCADA pack and put it in a box. You could pretty much use this for everything. You can see what I've done now. It's just like a little demo program that I don't know if you can really see that there. But basically you flip the switches and the relays do different functions depending on which switch is toggled. Your display shows you that the digital has been toggled. And each input has a different. That's a different switch function there. It does a different. It's just an example to show you. I mean, really, these switches can be used for changing set points, or manual control of something. Anything really that you want to do with it. Makes the system pretty versatile. So there you go.